So, was that fun or was that a dreadful experience? I hope that's fun, because if you're seeing this, then definitely you want to learn more and it was fun for you, or at least it was more insightful, it was a nice and new experience for you. I understand at times development cannot be all fun. Sometimes it is an hour long, that rabbit hole debugging. I understand. Anyway, congrats and kudos to you if you are watching this module, but one caution and one question: that have you implemented, or are you just watching like all the way? Just skip. I hope you are not doing that. So make sure you have implemented what we have implemented in the last segment, in our last module, because this module is the continuation of that. Because until now, we somehow got our left wheel and right wheel and base link up and running. We'll now see what mistakes did we make and what are the rectifications that we can do to our existing files. Okay, let's do that. So now your question would be, okay, we did everything same, then why are we facing issues? Correct? Let's figure it out. So see, this is the state publisher that we have received, right? This is the state publisher that we literally copy pasted. Okay, now let's see what's wrong over here or what's better over here. We can see the imports are same. Let me just get it side by side. And let me get our state publisher over here. Yeah. So we can see that the imports are exactly same, right? There's no difference. There's anything extra. There's nothing, anything less. So our imports are fine, right? Better. We then have our generate launch description. We have our package share. We have our default model path, and we have our robot state publisher, which is this. So then the question is, where exactly is the issue? Because our robot state publisher is same, our joint state publisher is same. Obviously, we are passing a different chacro file because that's the expected chacro file that we are getting into. Then the question is, okay, what is the issue? Can you guess? Okay, I'll give you a hint. You remember I said RViz is not a simulation software and it's a visualization software. Got it? No? RViz is a visualization software and we are using a parameter called useSimTime. And what is the default value that we have provided? So in our case, we have provided the default value as true, whereas in the state publisher launch file, we have the default value as false. And this exactly proves my point where I say RViz is not a simulation software. RViz is a visualization software. And for that matter as well, not only RViz, but even our state publishers are independent of that. Because the moment we use spawn entity along with Gazebo, I believe then using SimTime makes a lot of sense. But since when you are working with hardware, consider over here we don't have any simulation, which means that we have just a hardware that is publishing some data onto our RViz. Like imagine this hardware robot, this LiDAR, this base link, even these have to be supported via a URDF, right? Even these have to be supported via some chacro files. And even these have to be supported via joint state publisher and robot state publisher. So our state publishers will also be considering that all of this is just coming in from a non-simulation zone. And hence, a simple trick over here is to keep your useSimTime parameter to false. So now let us try that. So if I do this false, FALSE, okay, that's done. Let's do this callcon build. Build is done. Then I'll do ROS2, launch, robo AI, robot, and then main.launch.py. And There we go. We have found out the root cause of our earlier module's error. We did rectify partially in our earlier module, but this is even a better solution. So I hope now this is more insightful and more exciting. One more thing I'd like to do is I'll get the axis of our TFs like this. So you can see red axis is representation of x-axis, green axis is representation of y-axis, and blue axis is representation of z-axis. So it's the same analogy that I have given you earlier as well, which is like this. This is your red, that is x. This is your blue, that is z. And this is your green, that is y. And this is how exactly your robot transforms have been represented. I hope now all of this is making sense, like right from where we started our module, that's the last module where we saw how URDFs have been created, how we from scratch created a Chakra file, and right now to getting things in some sort of visual representation. Let's do one thing. I'll remove all the unnecessary things and let's save this. Okay, I'll click on file, I'll click on save as config, and I'll go. So in our previous module we did saved a ROS configuration, right? So I'll just go and overwrite that inside config, and this is our ROS config. I'll just click save and I'll say replace and done. Now if we use that ROS config inside our launch files, whenever we launch our ROS, we will have our configurations up and running. Let's close this. So I'll remove this part and I'll uncomment this, and we don't need this. And what I'll do is I'll simply cut all of this, and we have our state publisher file now. I'll simply paste it over here. There we go. Now we don't have to include everything in one single launch file. We can have separate launch files. And let's name this launch file as rviz.launch. So we'll simply name it rviz.launch.py instead of main.launch. And we don't need this. I'll remove this. But we need sim time, so we pass that. Then we don't need this. I'll remove this. We don't need this. We'll remove this. There is another thing that we can use is our node segment of it. So I'll just import node from my launch. Let me just check what was it. Is it launch.actions or if it's something else? It's okay. It's from launch_ROS.actions and then node. Yeah, perfect. So what I'm trying to showcase over here is, if we have one single node, I mean, it's okay. There are two ways to do it, or there are actually many ways to do it. This particular way is one way. Another way is, we can simply do is the node, and we can have the package name, package equals to rviz2, and then we have executable, which will be again rviz2. Then we have name equals to rviz2, and then we have output equals to screen. Next we have parameter meters equal to, open brackets, curly braces, use sim time colon use sim underscore time, sim underscore time, and then we don't need this node. If we remove this, it's of no use for us right now. So let's see if this works. Let's see if there are any issues as well. I'm just showing you different ways how you can utilize this launch files. So let's build it, and let's only launch our rviz.launch. I'll do ROS2 launch robo AI rviz.launch.py. Okay, it says that missing one required keyword, only executable. The launch file may have syntax error or its format is unknown. Okay, let's see. What are we missing? exe executable. Okay, let's see if I can find an example where it's the same thing, right? Executable. Let's comment this. Let's do call con build again. Let's try it. And there you go. Definitely I messed up the executable part. Yeah, there's a typo. Now I see that. There's a typo in CU80. Oops. It happens. It happens. It might happen with you as well. Okay, so that's it. That was just one way to showcase, how we can utilize our launch files to launch nodes. Now it's your call, however you want to launch it. But I'll just mention one thing. If you're working with the team, try having a consistent way of doing things. Okay. Now let's get our state publisher up and running as well. Let's see if we have anything over here. Okay, so let's quickly revise what we are doing, what we have done. We remodified our rviz.launch. So we had main.launch, we converted into rviz.launch. In that main.launch, we also had our state publishers. I removed it and I created a new launch file, that is state underscore publisher dot launch. So all our state publisher is in one zone. Okay, one more thing. If you have noticed one more thing, that we haven't utilized the use sim time as such. Like over here, we have use sim time, but it is not declared anywhere what is the default value. So if we remove this, let's remove it from here as well. Let's save it. And then let's try to build. Let's see what happens. We got our rviz up and running, which means it's not compulsion again to pass in the use sim parameter for rviz, as we see over here. That's another insight while building this package. Similarly, let's see if things are over here correct. Yes, not this. Yep, state publisher. So we have our sim time, but what happens if we don't include this? Comment this. I'll comment this, and I'll comment this. So we are again not utilizing our sim time. Let's see if it affects here. I'll do callcon build, and I'll do ROS2 launch robo AI, and then state publisher dot launch. And as you can see, we have our base link up and running. So for now, we'll remove this. If we require later on, we can add it. Similarly for rviz, if we require, let's say if we start working with Gazebo and we get to know, oh, Gazebo requires use sim time, like when you're working with Gazebo. If that's the case, then we'll add it. But for now, we'll remove it. We'll try to keep our files as clean as possible so it's easy to understand. Okay, so now getting back to our chakro files, we'll remove all the other chakros and we'll try to build things up whenever necessary. Now, one query you might be having that here we just have link name, nothing else. No visual property, no inertial property, nothing. You might ask, okay, isn't that necessary? Well, it depends. Like, it's necessary technically, but right now, since we have just a bare bones structure, it's not necessary. And secondly, we are not trying to create a very realistic application over here. All we are trying to do is get our robot up and running, and we can move around it. But when you're building a very realistic simulation, at that time, it is required. Where you want a simulation, it is very close to your application, where it's very close to your desired application. At that time, it's necessary that you mention all the inertia and the physical and visual properties as they are in real hardware. So that's another insight. Okay, so now we have cleaned up all our files. We have removed all the unnecessary things, at least for the time being. Now let's add another links. Let me just check. Yep. Yeah, one more thing we can do is we can add our config. Let's do that. So I'll close this. And what we'll do, we have a config folder, correct? but that config folder is not being added inside our CMake list. So let's do that. We'll add a config folder. So inside our main directory, we have config folder, we have launch, and we have models, correct? Yes. So let's just save it. And since we are here, we shall also add our configuration file, that is our rviz configuration file. Let's have a look at our rviz config. Okay, so it's simply an argument that have been utilized over here. So just go arguments equal to -d comma launch configuration, and then the file name that we have. So our file name is, before that we have to create a base configuration. So that's there, we need to do that. Yep. So we'll just name this. Okay, so right now we are naming our launch configuration. Let's do it rviz underscore config. Okay, that's the name. Now we also, did we misspell this? Yes, launch launch configuration. Okay, that's perfect. Now, as I said, we need to create a config, that is our default rviz config, rviz config, and that would be os.path.join. And here what we can do, we can either create one single path, or we can then utilize the method that we use where we have a prefix and then we join it. So let's have that. Let's have that. We'll have pkg underscore share launch underscore ROS dot substitutions dot find package share, and then provide the package name. So package so our package name will be the same, roboai underscore robot dot find, and then roboai underscore robot. Okay, I didn't get the ROS launch launch underscore ROS substitution. Launch dot substitutions. It's launch underscore ROS. Okay, let me just check with my state publisher. Yeah, so it's launch underscore ROS dot substitutions and then find package share. It's correct. Let's just copy this part and I'll paste it over here. But it's still showing issues with launch underscore ROS. Why? Oh, yes, because I believe we need to do import launch ROS. Yes, that one import was missing, which actually was throwing that error. So we have that now. And yeah, done. So now it's time to include this over here, and then we have we have config. What's our path? Our path is config, and then inside that we have rviz. Let me just open my config file. We have rviz underscore config, rviz underscore config dot rviz. There you go. Now it's time to create the return part of it, that is a return launch description. So I'll quickly check on to this launch file how it's being done. Okay, so we have launch action declare launch argument, and then we pass in our argument name that we created above, and then we pass the path. So let's do that. Since we don't have sim time, I'll remove this and go launch launch dot actions dot declare launch argument. Then we have name equals to rviz underscore config. Then we need the default value, default, default value equal to default underscore rviz underscore config. Oops. Yeah, default config. That's done, and then we have description, and it would be absolute path to rviz config. Okay, that's it. Looks like we are missing something. Yep. Okay, that's it. Let's try and launch our ROS node and let's see if things are working. And we'll do over here ROS2 launch robo AI, then rviz.launch.py. Okay, good. We have things working. We have our rviz config over here. That's great. Let's close this.